All right, welcome everybody to CSI 41, week 12, day 2. We're going to be talking about the last big topic in this class. We got some other data structures we want to get to. I want to get to heaps, I want to get to quad trees, treeps. There's a couple good data structures left, but there's a big learning point, and this is the last major chunk of C++ you kind of have to know. We are coming to the end of our basics of C++ journey today. Basically, we're coming to the end of the basics. You will never finish learning C++. You will never be done learning C++. You will die first. We're going to do inheritance today. Yeah, absolutely. So, inheritance is a major topic in computer science. It is part of object-oriented design. We have been doing object-oriented design this whole semester. CSI 40 first semester is very procedural. It's like how you program in C. Main has all the brains, does all the things. In CSI 41, we learn object-oriented programming. And object-oriented programming involves having classes that have data and operations you can do on the data. And the topic today is inheritance. And it's one of the core parts of object-oriented programming. And it actually took a while for people to get right, apparently. I attended a talk by Barbara Liskov of MIT, who was one of the people who invented the notion of inheritance and how it should work and things like that. And they worked on it for a long time to get it working. And so nowadays it's just kind of an assumed fact. If you're doing object-oriented programming, this is how inheritance works. But what is inheritance? Okay, let's get into that. So inheritance is a way of avoiding copy pasting code. That's second class. So if you have one class and your one class has all this stuff in it and you want to make another class that's similar but different, we use inheritance. Inheritance is a way of avoiding copying and pasting. You never want to repeat yourself, right? There's a principle in computer science called DRY, right? DRY stands for don't repeat yourself, right? Don't repeat yourself, don't repeat yourself, don't repeat yourself. If you ever find yourself copying and pasting large chunks of code, you should feel a little guilty about it, because copy-paste errors are very common. But it also means you've got the same code twice, and if there's a bug in one of them, there's a bug in both of them. And if you fix it in one place, you probably aren't going to fix it in the other place, unless you just happen to get lucky. In fact, just yesterday, Benninghoven, who's giving an X credit workshop on Friday, I was showing him some scripting, and I realized I had a copy-paste error in one of my shell scripts. And so, I copied and pasted it. I had changed a variable in two places, hadn't changed it in the third. Turns out that branch just almost never comes up, and so I just had never noticed it before. If it was in your input tester, none of you noticed it either, because it just never comes up. But, don't repeat yourself. Okay? I'll say it again, don't repeat yourself. So, let's get into it. Let's give you a real-life example of where inheritance. He said you will never break free from C++. I didn't say that. You can always quit C++, but you will never finish learning C++. Let me put it that way. You will die first. you will never. The journey never ends, except through death. So, inheritance. So inheritance is a way of copying and pasting code. That's the best way of thinking about it, I think. So, So inheritance allows you to borrow code from old classes. Okay. So for example, if you've ever used iStreams before, does anyone have an example of a variable of type iStream? Not ice cream, iStream. Goes to hell. We're going to need to learn a new algorithm in C++. It's quite possible. Hell always needs more C++ programmers. It's their primary language, but not modern C++. Pre-standard C++. That's all they use in Hell. iStream, Ustream, we all stream for iStream. Hell uses C-style arrays, exactly. So, a variable of type iStream. Have you ever used the variable named? Do I have a thing here? power? No. So my tablet's not powering up. There we go. Unplug it and plug it back in again. There we go. So variable named cn. Have you used this? Cn into x, that kind of stuff. Yeah. So cn is of type iStream. Okay. And it's any input stream is iStream. Okay. Now, OStream is like the type of cout. So cout's type is OStream. Okay. And there is a lot of code in getting these things to work. Believe it or not. Just printing like a float or a double is extraordinarily complex. And the reason why it's complex is because floats and doubles are held in what's called the IEEE, with the accent over it apparently, 754 format. And this thing is a bit monstrous in terms of details and things like that. It's got positive infinity, it's got negative infinity, it's got positive 0, it's got negative 0, it's got quiet nans and signaling nans and denormals and all this kind of stuff. And if you were to just like see out like some floating point number, and if it's like 3.1, it'll come out as 3.1. But if it's like 3.1 times 10 to the 7th, then it actually writes it in scientific notation. And so there's a lot of code that actually goes into there's a lot of code that goes into making reading and writing just floats and doubles correct. And Betancourt and Aaron and Mincarelli are actually in CSAT 45 right now, where they're learning IEEE 754 format, and it's a thing. It's a thing. It's complicated. You don't want to have to write this twice. Let's put it that way. If you look at how many lines of code there are in just IOStream. Right, how many lines of code are in this? G++-E main.cc pipe through word count long. 44,000 lines of code. Our Hello World program is 44,000 lines of code. Okay. So, there's a lot to it, is my point. Like getting, all the, and that's just floats. Like you have to, cin and cout have to know how to read in ints and unsigned ints and floats and doubles and strings and all this kind of stuff, right? It's actually quite complicated. And now let's say you got it working. You got cin done, you got cout done. You're like, yeah, 40,000 lines of code done. Now you got to write f streams, okay? And you know how to make a file, right? ifstream ends file.txt. It'll open a file named file.txt, creates a variable named ends, and then you can do ends double left arrow f or whatever. This code to print f to the screen is exactly the same code as to print f to a file, right? You don't want to have to write it twice. Trust me, you just finished writing 44,000 lines of code to get all this nonsense working. You do not want to have to write it a second time, especially when it's exactly the same code, right? Figuring out if it's a scientific format, figuring out if it's a denormal, figuring out if it's -0 or +0. Like who wants to do this twice, right? What the hell is -0 anyway? I don't even know. What is -0 times +0? I don't even know. And if you have a bug in one place, like if you have a bug in couting -0, and you copied and pasted it to make this one, you're gonna have a bug there too, and you have to fix it in both places. And then you finish that, and now it's time to do an iStream stream, right? String stream, blah, blah. You know what I mean. Then you gotta write it again. Hell no. So what we do is we do, what about my read.h? Yeah, okay, let's try that out. My read.h includes IOStream, so it's going to be bigger.
30,000 lines, Ernie.
Huh?
31,104 lines of code.
For what?
for your read library.
Okay.
If we do the dash E.
Let's try that out. 49,000 for me. There may be... I don't know. Let's try not using the alias. Yeah. So by switching to C++20, there's actually a fairly substantial difference in bloat in the headers. That's one of the downsides of C++20. Is that actually compile times have gone noticeably worse. Especially if you use things like ranges, which are really nice. Be able to just say sort vec instead of sort vector.begin, vector.end. It's really nice, but for some reason, and they're still working on it, it drastically slows down compile times. So, there you go. That's one of the downsides to using 20. Is like you can, and yeah, maybe it's just the, maybe it's just this. It could have been the other options too. C++ 20. Yeah, so just turning on C++20 adds 11,000 lines to the headers, which is a lot. Okay. So, yeah. So you finish writing iStream, you got cin, cout working, then some joker comes by and tells you to do files, then somebody comes by and tells you to do string streams, and you do not want to copy and paste all of that code again. You guys with me on this? Trust me, forget about it. Okay? You guys understand where I'm getting at with this? All that code is going to be the same. The code to print a floating point number to a file, the code to print a floating point number to the screen, the code to put a floating point number to a string. It's all the same code. It has to read the IEEE 754 format and look at the bits and the mantissa and the exponent and all that kind of nonsense. But it's all the same. Right? You don't repeat yourself. And so what you do is you use inheritance. This is the syntax. Okay? And so what this is saying is we are making a brand new class called ifstream. And we are going to copy and paste all the code from iStream. You don't see it here. This is the whole thing. Oh, shoot. Why do we not have a semicolon here? Who writes this kind of... Who wrote this slide? No semicolon. All right, never forget this. So what this part here means copy and paste. This is a Control C followed by a Control V into your code here. All the private sections come into the private section, all of the public sections, maybe these aren't the best arrows. The private section comes into here, the private section, the public section comes down here into the public section. Everything's copy and pasted invisibly, okay? It is invisibly copied and pasted in, and then all you have to do is write the stuff. All that you have to do is write the stuff that is different, okay? And so for ifstream, all you have to do really is, and we probably need a destructor in here too. ifstream, whatever. All we have to do is write the code that makes it different, okay? So all you do differently with an ifstream than a regular iStream is that it can open and close a file, right? So you got a function called .open, .close. The constructor, if you pass it a string, it'll call .open. When it goes out of scope and the destructor is called, it calls .close for you. That's basically about it. And then somewhere in like the private section here, there's going to be like some sort of buffer or something that it reads and writes to. And basically, when you have a file, it's going to read and write to the file instead of to the keyboard. Somewhere within there, something's going to be like, nope, this is the file descriptor we're writing to, and that's probably just an integer, maybe. You know, it could be as simple as just an integer. If you're writing to the screen, that is going to be 1 or 2. It's an integer. File descriptor 1 is standard out. File descriptor 2, standard error. File descriptor 0 is the keyboard, right? So, you know, this will probably be reading and writing to file descriptor, reading from file descriptor 0, and then this will open a file and save the integer for whatever the file handle is into that integer. I don't know how they implemented it, but it could be as simple as just changing an integer. Okay. And so, would iStream be virtual? Nope, because iStream can actually be implemented itself. It is not a pure abstract class like we used for the hash assignment. This is actually the type of cin, I believe. So it's iStream cin. Okay. But let's check. I honestly usually don't dig into the headers because it just works. Let's find out. Pipe through grep cn. Yep, there it is. So what I just did is I just looked through all the header files. Grep is going to search through all the header files. Wow, that was loud. It's going to search through all the header files for... Oh, somebody's on my front yard. Oh, Amazon just delivered. I just installed an internet... I upgraded the security at my house yesterday, so every time somebody walks in my front yard or goes to my door, my phone beeps at me now. I'll probably have to do something about that. Whoop. Mute. Thank you. Okay. Yeah. So what we have here is we can see that cn is of type iStream. Cool. All right. That's its type. Good times. Good times. No. Did somebody actually go to my house for a slice of pizza? No. I was mostly just doing that to troll you. Although if somebody did want to, I probably would have set up a folding table at 1 o'clock in the morning with a handwritten sign in crayon saying free pizza and just put a box of pizza out on the grass. People can sneak in like rats and steal slices of pizza. Kearney's more secure than Fort Knox. No, not really, but it is interesting. Like the way that security systems work are actually quite interesting these days. The cameras themselves have like an AI system in it that can detect people and cars, and so like if a cat walks into your driveway, it doesn't alert, but if a person does, then it does. And you can actually set up a 3D zone, and you can make it when people enter the zone it alerts, but not when people leave the zone, or you make it when people leave the zone. So for example, you can have your backyard. And say if your kid ever leaves the zone, then beep, or whatever. And if somebody crawls in, will it detect them? I don't know. We'll need to get a bunch of students like take one slice, takes the box. I know that during the pandemic, I didn't want to get near trick or treaters, so I just put out a jack, like a plastic jack-o'-lantern. With candy in it, just said take one, and some took the whole thing. So, really, you're stealing Halloween candy from kids. They took the entire thing, whole bunch of Snickers. Like, oh yeah, I could have checked on the security camera, huh? Yeah. So, yeah, that's true. So now I'll have a record if somebody takes the whole pizza. All right. So anyhow. The type of, so this is not pure abstract, this is of type iStream. And if you were to make a file, that would be of type ifstream. And what this does is this says copy and paste all of the iStream code into ifstream, and then we can just add a little bit of extra functionality. We're just going to add the functionality to open and close the file, and we don't have to repeat ourselves for all that code for reading and writing floats and all that, just horribly annoying stuff. Horribly annoying. I have written it myself. Because it includes things like, all right, print this integer in hexadecimal format. Like, there's a lot of options in there. No, I do not ever want to write it again. I want to use other people's code that works. Okay. Probably a kid doing it. I don't know. If I do it again, I'll definitely have the camera ready. Okay. So basically, because ifstream inherits from iStream, all of their stuff gets copied and pasted in. Okay, so the only thing we have to do for ifstream is to add new functionality, right? And all the stuff we had before with like the double left arrow operator, the double right arrow operator, they're all there. They all work. If you want to call the constructor from your constructor, you do this. So this is how you chain constructors together. This is really important. We've talked about shortcut notation before in constructors. And before I said it was kind of optional, if you initialize something, a member variable using shortcut notation, it's better because you do consts and things like that. Here it's necessary, okay? So this is chaining a constructor together. And this is actually really important. So if you have a constructor on a parent class, you have to do this. So this is my constructor, and it's going to call the parents constructor. So that's going to initialize all my parents member variables, whatever they have. They probably have some buffers and all this other stuff. That's going to have my parent initialize all their stuff, and then we're going to do our constructor stuff, which is just going to call open. It's going to open the file name and whatever. Okay. So, how come you created one yourself? I was working for a electrical engineering company, and they had a bunch of like hexadecimal data, and I needed to parse it, and it wasn't immediately usable in any sort of recognizable format, so I ended up basically reading a bit at a time. I was actually reading a character at a time, but I was like processing almost a bit at a time to decipher this weird binary format they had. And no, it's not fun. It's yeah, it's nah, not the kind of thing I enjoy. And then of course, like I had to implement it in 45. In C-Site 45, a very traditional homework assignment is write a function that will output a number in hex, convert between different bases, octal, hex, binary, and decimal. I'm not doing that with you guys this year. Maybe I will. It's a very traditional assignment. You know, write a program that converts between binary and octal and hex and decimal. It's kind of boring though. Okay. Is inheritance related to operator overloading? It's not. Operator overloading, so iStream will have an operator double left arrow, right? So it's going to have some sort of operator double left arrow defined in here, you know, to see out things. Or no, sorry, this is iStream. Sorry. Double right arrow to see in things, right? And because we're inheriting from it, we're going to get one too. And that's how you can read from a file using double right arrow. You don't have to overload anything new. It just copies and pastes the overloaded operator for you. Okay. And one of the benefits is that when you do this, you can pass an IF stream, like we had our variable named ends, right? You can actually pass that to any function requiring an iStream. That's cool, right? So when we did all of our overloaded operators, we would have like operator, double left arrow, and it takes an O stream, right? By reference, blah, blah, blah. If you inherit from an O stream, you can pass anything that inherits from an O stream to it. So this function takes an O stream and returns an O stream. Because we're doing that, we could pass an OF stream to it. And we could pass an O string stream to it. Anything that inherits from a class can be passed in lieu of that class, which is really nice. So you don't have to have a separate operator overload for IF streams. Just all these functions, your double left arrow operator, right? It's O stream, ampersand, operator, double left arrow, O stream, ampersand, outs. Remember that? So this will work with any O stream or child class. It'll work with all of them for free, automatically. It's nice. Don't have to copy and paste yourself. You want me to do it? All right, we'll do it. Hex convert, coming your way. Okay, so let's go with a simpler example here. All right, so just as a really simple example of how this works, because all that stuff we were talking about, you're talking about thousands and thousands of lines of code. Here we're just going to do a really simple example, just showing you how it works. What's the troll face for, Bencourt? Oh, you don't want to do the hex convert? It's classic. It's a classic assignment. You want to? All right. We'll do it in assembly. It'll be fun. Okay. So, yeah. So we've got a class here named A, and it's got a member variable named foo, and we'll talk about what this means in a second. And we just got a getter and a setter. Like, this is a very basic class. All of you should be comfortable with this. It's got an implicit constructor. This actually generates a constructor for us. You don't see it here, but one exists. It makes one when you do this. Getter, setter, private member variable, constructor. This is a basic class. You guys all with me on this? Do you have any, other than what protected means, do you have any questions about this class? Is that the letter O? I don't know. No. 0, O. Maybe. I don't know. Which ones are zeros? Which ones are O's? Who knows? Will it compile? I don't know. Okay. So, all right. Any questions about this? No? Should be good. Absolutely disgusting. Yeah. Otal, does this make sense? Okay. So, yeah, protected here, I'll explain this. It basically means private, almost. I'll explain the exception in a second. It's almost private. It's very close to private. All right. So main can't access it. Okay. Here we go. So this is how you inherit, right? So we're going to make a new class called B, and we are inheriting from A. And you're always going to do colon, public, and then whatever the name of the class is. That's how you inherit. And a lot of students ask, what does that public mean? And the answer is always use public. It's a stupid design that you need that. If you don't have it by default, it does something called private inheritance, and private inheritance is almost always the wrong answer. Private inheritance is almost pointless, actually. But that's what it defaults to, because C++ is a language with dumb defaults. Structs default to public inheritance, classes default to private inheritance, and it's just widely regarded as a dumb decision that you have to type this every time, but you do. So it's just memorize this. Just always use colon, public A. Okay? You're always going to use public inheritance. And what that means is it just means copy and paste the whole thing in. Things that were private before are private now. Things that were public before, public now. Things that were protected before are protected now. Okay. All right. Why is private inheritance so bad? So if you left this off, everything that was in A gets copied and pasted into the private section. So it's not usable. So if you had a function here called, Bob or whatever, in the public section, if you did private inheritance, it would go into the private section of the other one. Yeah. It's almost never what you want. Okay. There are uses for it. There's you can find C++ nerds online. They're like, yeah, I use private inheritance all the time. Yeah, it's just no. You're just always in this class, at least. You're always going to do this. Okay, it's. I'm not going to say it's 100% pointless, but I'm just going to say it's 100% pointless, and I will be wrong some fraction of a percentage of the time. How about that? Okay. So Geeks for Geeks probably has an example of using private inheritance, and there's design patterns and things like that use it, but not in this class. You're just going to do this. Okay. So what happens is that this is going to copy and paste everything from A into the relevant sections. So we are going to gain int foo. Int foo here is going to get copied and pasted in here in the protection section. It's int foo equals 0. And get foo and set foo are going to be copied and pasted over. But get foo is going to get overridden. So this is an override. So this is actually going to change the function. Okay? And so you can copy and paste things, and you can still change them. All right. So this get foo function, for whatever reason, this is a very contrived example. I apologize. It's just contrived. But when you call get foo on a B, it's going to add 100 to foo. Whereas in the original, it's just, and that should be const right there, huh? Who made these slides? Let's fix this. And it should also be const override. Whatever. Okay. So if we make somebody of type B, it's got a function called get foo and get bar. A just has get foo on it, and set foo, of course. And so if we make a variable of type A, we can set foo to be 10. B can set foo to be 10. It's all still there, even though it's not visible. That was copied and pasted in. It still works. But when we call Alice's get foo, it calls the original one. When we call Bob's get foo, it calls this one. And so this is going to return 110. This one's going to return 10. That makes sense? So basically the point here is that you can copy and paste code and then change it, right? Or add to it. Like this is adding to it. This is like making a new thing. and then this one is like changing it. Does that make sense? And that's what that override keyword was for. The override keyword, if you remember that from the hash table assignment. The hash table assignment, override means it must override a function. Because sometimes you screw up, and sometimes you rather than making it a void, you make it like an int or something. And you're not actually overriding something you thought you were overriding, right? Like I thought I'm overriding this one here, but I'm not. And it gets mad at you. Okay, so note overridden function. Okay, if you're overriding something, that the override keyword doesn't like do anything. Like it's not. It doesn't generate any different code. Like if you had this code, you had this code, the code made is exactly the same. There's no difference. What it is a way of you expressing that I am trying to override something on my parent, and it keeps you from making a copy paste error. Like if you change something up in the parent, you don't change it in the child class. If you have the override keyword on there, it'll detect it. It makes sure that you're overriding something. It just stops stupid mistakes. It's a good thing to put in there. You don't have to, but you should. If you're overriding something, you should put the override thing in there, and it'll stop. It'll keep you from making mistakes in the long run. It's good. It's a good thing. Okay. This one is marked as both const and override because it doesn't modify the hash table because it's just searching, and it is overriding a parent class function. If you want to add something new to a child class, would you have to add it to the parent? Nope. That's what this slide here shows you. This is a brand new function. It's never been seen before in the code. That is not part of the A class, right? Get var. No. So you can add things, you can change things. Okay, you can add new member variables and y. So you can add on to it. You can add on and change things. The benefit though is that you don't need to copy and paste all of the parent class into the child class. That's nice. If there's a bug in the parent class, you fix in the parent class and it will automatically be fixed in the child class. That's nice. Also, when you pass a to a function, if you have a function that takes an A, it'll also take a B. That's nice too. That's cool. So you don't have to rewrite. You don't have to write a new function instantiation for each child class. If it works for the parent class, Liskov substitution policy. It'll Barbara Liskov, the woman who gave the talk at SIGSU. If a function takes an A, it will take a B. Okay. If you don't declare int get foo, here, it's like, let's erase this real fast. This will still compile. Anyone want to guess what value it will print out to the screen? Polymorphism. 10. It'll print out 10. Because all the code from A is copied and pasted in here. So we've got int x equals 0, and we've got int get foo that returns foo, or foo, I guess, whatever. And so it's just going to return the value of foo, which is 10. So it'll behave exactly the same way as before. So if you don't change it, the behavior on A and B are going to be exactly the same. Okay. It just copies and pastes all the code, and if you don't change it, you don't change it. And that's what happens most of the time. B will behave exactly the same way as A. Now, let's hop onto the server and look at these fantastic C++, never change, never change. Okay. That's just the one thing about C++ where the critics are right, which is the template substitution errors. Okay. Modules will help. Concepts will help. All right, let's do this. So let's, the example I used in the earlier class, Aaron remembers, is animals. For some reason, every time, it just seems to be a rule that every time you talk about inheritance, you have to either talk about shapes or you talk about animals. And it doesn't make any sense to me. It's a dumb example and it doesn't make any cognitive sense, but it's tradition. Like Hello World. Like, why is Hello World the first program we always write? I don't know. It's lost to the mists of time. But we're going to do animals. So we're going to make an animal class. And our animal class will have a protected section. And I told you protection. I told you we're going to explain what that means in just a second. And we're going to have health and how many legs it has. I don't know. And we'll have a public section. And the public section will have a constructor. And the constructor will set health equal to 100%. And the number of legs will default to 4 for an animal. And we will have a speak function because for some reason that's the example they always use when talking about inheritance, and it will say cout I am an animal with health and legs. Okay. I can't give you any better explanations than that. That's what we have. And then let's make a bird class. All right, class burb. Okay. And the burb class will add wings. And it's going to be how many wings burbs have by default. Such a dumb example. It's like insects. Insects have wings also, right? Call this flying animal. Okay. And it will inherit from animal. Okay. And flying animals will have wings, or maybe if it's a flying squirrel, I don't know if that counts. Is that flying? It's more gliding. We'll just go with this. Okay. Bats, bird. You've seen the animal example too. Yeah, it's everywhere. And it just kind of drives me crazy because you wouldn't actually write code like this in practice. It's just, for whatever reason, it's just always the example they give in like talks on inheritance. Like I've sat in on many lectures on inheritance. It's just like, it's either shapes, like I'm going to make a shape class and I'm going to make a rectangle class and the square class is going to inherit from the rectangle class, and it makes no sense. It makes no sense. Okay. Okay, so we need a public section here. It will make a flying animal constructor. It will initialize wings to be 2. And we will have a fly method on it that will say cout I'm flying. Okay, whatever. And we will override the speak method and say cout. And the fly method, of course, should be const, and the speak method should be const override, just to make sure that our we haven't gone over virtual yet. Just put that in there and explain it later. Okay. You mad? You mad? What's wrong here? Whatever. Let's not worry about virtual for now. I don't want to dip into that today, actually. So let's just override it the old-fashioned way. Okay. And so I'm an animal with health and legs, and I can fly too. Okay. And I can fly with my wings. All right. And then we can make a function called damage animal, and it will take an animal by reference named mol, and it will take an amount of damage. Minus equals damage. Will this code compile? I'm going to explain protected in a second. I still haven't. It's like private. Just think of it as private for now. Okay. No const? Oh, yeah. Thanks. That's, yeah. Thank you. And that's what the override thing does. It stops you. Because if one's constant and one's not, it doesn't override it. So, yeah, so the override keyword actually did its job. So, good job. Nice. Okay, thank you for picking that up. I completely didn't see that. Thank you. Okay. Mol. Am I allowed to use double left arrow end line in that bracket? Like you wanted to use, you want to do this? Damage isn't initialized. Damage doesn't. It's a parameter. It will be passed in by whoever calls the function. So was that you're asking, Laura? Okay, yeah. It's just less typing to type \n. It's also arguably faster in running time. So yeah, it doesn't work because this is a private variable. It's a protected variable, right? Remember, protected basically means private, with one difference that we will get to. Okay, so can't do this. Now we can mark this as a friend, right? So we could say, that's the next line here. Okay, so we could say friend void damage animal ampersand mal and damage there, and now it works. So remember, friends can access your private and protected member variables, so it works now, right? You can grant access to an external function if you want to do it that way. A better way would be to have getters and setters and the usual stuff, but it's always kind of worth reminding people what friends are for, right? So let's do this. All right. So we've got an animal here called monkey, and we don't have any parameters on the constructor, so we just do that, and we can say monkey.speak, and we can damage the monkey, damage animal, passing in monkey, and doing 10 damage to the monkey. And then the monkey will speak again. And this is literally like what every YouTube tutorial on inheritance is, and I apologize again because it's a stupid example, but it's just tradition. I don't know what to tell you. So here we go. So we're gonna have the monkey speak. It's gonna say I'm an animal with this much health, etc., etc. It's gonna be damaged. We're gonna speak again. Or close button. I'm an animal with 10 health and 4 legs. I'm an animal with 9 health and 4 legs. So monkeys don't have 4 legs. So we probably should get a getter and setter here. Let's do it a little more properly. Int new health plus 100. Int new legs. You got new legs, Lieutenant Dan. Equals 4. So we're going to default to 104. Here, do a little more proper like new legs, and then when we make the monkey will have 100 health and 2 legs instead of 4. Unspeakable violence. There we go. So we got 2 legs now. Okay. All right. You guys see what I did there? So I just added a couple parameters to the constructor, and because I use default parameters, it would actually still work with no parameters. Like if I passed in nothing here, it would default to 100 on the health and 4 legs, but it was kind of bothering me to have a monkey with 4 legs, so I added an option for that. And so you can see here we got a speak function, and every time the monkey speaks, it says, I am an animal with this much health and this many legs. Okay. We can damage it. Now, top-notch code you program there. Thank you. Limbs. Yeah. The entire example is contrived anyway. I'm only going to work with the work in the milieu to a certain extent. Okay. Now we're going to make a flying animal. So let's make a flying animal. Flying animal named bat. Okay, and it will have 50 health and 2 legs. And then it doesn't like you. Right, because the constructor doesn't do it as well. Right, so, right, we forgot this. Right, forgot to chain the constructors together. Always good to double check this stuff. Okay, so we are going to take int new health equals 100, int new legs equals 4, int new wings for the wing stop equals 2, and we will chain this with animal, passing in new health and new legs and wings like that. And there we go. And then that works. I could pass in the number of wings if I wanted. And then I can say bat.speak. We will damage the bat by 10 points, and we'll have the bat speak again. And so you can have the monkey still here. And then the bat says, I'm an animal with 50 health, 2 legs, and I can fly with my 2 wings. That's not correct. I passed in 777 is the number of wings. Oop, my face. That is too funny. Okay. New wings. There we go. Always test your code. There we go. So always test your code. Every time you write something, test your code thoroughly. Okay. So appendages, extremities, peripherals. Okay. So yeah. So oh, the bat did not take any damage. Okay. And the reason why the bat didn't take damage was because I copied and pasted. This is why you don't want to repeat yourself. Every time you copy and paste code, there is a possibility that you introduce a bug, a copy-paste error, just like that. Yep. Which I did, of course, deliberately as a learning thing for you all. Okay, and there we go. So test your code thoroughly. There you go. So the bat is now taking damage. It's got 777 wings. It's a seraphim, I think. Got a monkey. Okay, so do you see how this is working, though? So we've got here a function called damage animal that takes animals, but look, it also takes flying animals, right? I didn't have to write a separate version of it, okay? And so this is learning point 3. You can pass a child and it just works fine. Okay, don't pass it by value. We'll get into that on Friday. But if you pass it by reference or if you pass it by pointer, it'll work just fine. Now, what are other learning points? Well, first learning point is called this right here. Learning point number 1 for today. Inherit via colon public base class. Okay, that's how you do inheritance, like that. And now let's come to the point of protected. This is learning point number 2 for today. Protected is like private, but your children can access. Okay. If you do private, watch what happens. Huh? What? Yep. This function no longer works. And the reason why it doesn't work is because health and legs are private. Private members can only be accessed by yourself and your friends, okay? That's it. And so if you do inheritance, it doesn't work, okay? That's what protected is for. Protected grants access on a member variable to the children, the child class. Okay? So it defaults to private. If you're doing inheritance, though, probably a lot of that stuff should be protected. Now, there is some like philosophical disagreements over whether protected is better by default or private is better by default, and I'm sort of it just kind of depends on your needs, right? Like if the subclass needs access to these variables, you have to make it protected so that they can access it. But some people would say make it private and then use get health and get legs instead, and even in the child class to use the getters, right? So private variables are only accessible to that class, not in main, not to a subclass, right? Only to itself and anybody that you friend. Okay. So protected grants access not to main, but it grants access to the subclasses. And so if a subclass needs access to health or to legs, then it needs to be protected instead of private. And so a lot of times when you work with a lot of inheritance, you just make everything private protected instead, just to make your life simpler. Like I said, there are some people that will go into a frothing rage if you suggest that. They say, no, private variables should be private. They're private for a reason. Even these subclasses should use getters and setters. It's a philosophical issue. You're not going to hear me take a stand on it, you know. So, you can do it either way if you want to make your code work. And, you know, there's people will get into these long, tedious flame wars over philosophy of object-oriented design. I'm just here to tell you how to make it work, you know, and you can choose for yourself which way is better. Who cares as long as it works? Well, because when you get down to it, right, like at a certain point, this code's going to be in production and it needs to be readable and it needs to be maintainable, right? And so if it's 100 years from today and somebody's coming in and they're like, all right, where, you know, you got 9 million lines of code and they're like, where is this variable coming from, right? It's not in this class. This class only knows about wings. This class does not know about health. Where is that coming from? You know, it's just a variable. Where is it coming from? You know, and if you've got 100 different levels of inheritance, trying to, you know, like you'll probably have like IntelliSense or something. You right click on it, and you're like, go to definition, and it jumps up 50 spots in the inheritance hierarchy. And you're like, there it is. There's health. Is that good design? I don't know. Probably not. Probably better to be private and just use get health and maybe, I don't know. But where is get health? I don't know. You know, like it's, I don't know. Who knows? So it's one of those things. Would you be able to keep track of all the children by using static? You could keep track of how many times you're instantiated. And then you could probably do some games with the child classes or something. I don't know. You know, you can have a static member variable for yourself and a static member variable for children, and have the children in increment one and the base class increment another, and then you can keep track of the relative populations. I don't know. Probably do something like that. Sure. Can't you just make a class animal? Make a few private pods like flying animal and use functions to access those private pods. You could, yeah. So there's a big philosophical debate over composition versus inheritance. And when I learned programming from Walt Savage, who actually just recently passed away, may he rest in peace. He's a great guy. I liked him a lot. I messaged him after I became a professor and told him, he taught me in the equivalent of CSI 40 and 41, and I'm teaching it now. You know, I was even using his textbook. I've got his, I don't know, what is that, 8th or 9th edition, something like that over there. 10th edition? 10th edition, yeah. Walt Savage loved inheritance. He loved inheritance. And when I graduated from college, actually before I even graduated, when I started working as a professional programmer, just before graduation, I loved inheritance too. Used inheritance for everything, you know. And there's downsides to inheritance that we'll talk about next time. And a lot of times what I found was that it was... What I found was that a lot of times people use inheritance to avoid an if statement. Like they go through all this rigmarole, setting all this stuff up, and all this could have been just inside of the animal class. You could have a Boolean, and the Boolean is like, I'm flying, and you know what I mean? And then the speak function says, if I'm flying, then do this. If I'm not flying, do that. You know what I mean? Like, people go to a lot of effort to avoid an if statement, apparently. So they kind of use or abuse the type system, depending on how you want to look at it, to avoid if statements. And sort of, yeah, for about 2 years, I wrote a lot of code with a lot of inheritance, and I'd make these big class hierarchies. Like, here's this type, and this inherits from this, and these two things inherit from this, and then, because you can keep going with this, right? Like, you can make a class bat that inherits from flying animal, you know, or you can make a flying mammal class that inherits from flying animal, and then you can have a class bird that inherits from flying animal. Like, you can make these giant class hierarchies. And what I found was it sucked. is what I realized. Like, at the end of the day, I realized, like, it sucked. Like, it was just annoying to deal with, right? Because, like, if you have a function like damage animal, okay, so damage animal will work with a monkey, it'll work with a bat. In fact, this person should be called flying mammal now instead of flying animal. And yeah, and I need to make constructors and all that for them. I'm not going to waste time doing it right now. But the damage animal function will work with all of those. But here's the thing, right? Like, let's say you want to have a function that works with different parts of the class hierarchy. You know, so like you might have birds, and birds inherit from flying animal, which inherits from animal. But you might also have flightless birds. So wait. Okay, so we're going to have to rename the bird class to be flying birds. And then over here in the non-flying animal section, we're going to have another bird class for ostriches and stuff. And I want to have a function that only works on birds, but they're in different parts of the class hierarchy. So I want it to work with this one over here and this one over here, but not with monkeys. And you're just like, because they're both birds, and so you want to, so you make another class called bird that, and then so you make another class called bird, and then you have flying birds and flightless birds that inherit off of that, and then it just, oh my gosh, like it just becomes very complicated. And every time you want to do something new, you have to decide which of those subtypes it'll work with, and which it won't. And if you have a random collection of these 3 subclasses should work with it, and these 2 shouldn't, then you have to make another and inherit off of it. And it starts looking like one of those like conspiracy theory like charts. You know what I mean? Like, this kind of stuff, right? That's what your class hierarchy starts looking like. You start just like having no idea where anything is, right? And all of that is just to avoid an if statement. You know, like your animal type could just have a Boolean on it called bird, is bird, you know? And then your speak function could have a thing saying, if is bird, do this. You know, all that work just to avoid an if statement. So, yeah. And so basically, yeah, for about 2 years, I really got into it and really did a lot of these really complicated class hierarchies and things like that. No, this is the wrong class. C++ complicated class hierarchy. How about this? There we go. Yeah. So yeah, this kind of nonsense here. So You see, this inherits from this, which inherits from this, which inherits from this, which inherits from this, which inherits from this. And they're not even doing multiple inheritance here. Oh, Lord. And you start to end up having these, like, you end up, like, charting things like Visio and things like that. UML diagrams. Let's see if I can find a good example of this. Yeah, that's pretty simple. Yeah, here we go. Here we go. Let's see this. There, is that a flow chart? That's a flow chart. Yeah. Yeah, I've done these before. So it's like this, and it calls this, and this is composited with this, and this is connected to this, and yeah, it I don't know. What I found, like I said, after about 2 years of doing it, was that I was fighting the complexity of the inheritance more than I was coding, right? Yeah, that's a good one. Inheritance equals BSD structure. I wish. This one is BSD structure, right? Because we have 2 flying animals, and right. But this is great. Yeah. So this inherits from that, and that inherits from that, and that inherits from that, and this inherits from both this and this, and yeah. So I moved away from it. In fact, my reaction to it was actually to move to a very primitive form of C++. I moved away from inheritance so hard, I ended up in C. I ended up living and working in C world, so to speak, for several years, in fact. Influenced partly by one of my heroes, John Carmack. John Carmack was doing a lot of coding in C at the time. Linus Torvalds also hated C++, he liked C. And so if you look at my code from the late 90s, early 2000s, it was very C-like C++. There are some elements of C++ I liked and kept, and a lot of it was just very C-like. Aaron's seen my code from that code period. A lot of pointers, a lot of, C, sort of idiom kind of stuff. And a lot of that was just a reaction to how much bad times I had using inheritance. And so my view on inheritance now is more balanced. I do prefer composition over inheritance. You could make a private struct or whatever, and like there's a lot of different ways of building a complicated class. And in general, I try to avoid inheritance. But sometimes it's the right solution for the job. For example, for the hash table assignment. Now that you understand it. Still need to talk about that on Friday. But what's happening here is we are inheriting from the hash class. And so the hash class gives us these 5 functions. They're all these 4 of them are deleted. And what that does is that anybody who inherits from hash must implement these 4 functions. And so it's an interface. It's a way of having main say, I don't care which implementation you're doing, just as long as you implement these 4 functions, I'll be happy with you. And then you can implement the class 3 different ways, however you want. And down here in main, there's one line of code that's different, right? You either set table equal to a linear probing hash or a chaining hash or whichever your other one was, double or whatever. And that's the only line of code that's different. After that, no difference at all. When you're down here, all of this code is the same. All the code using the hash table is the same, and the implementation is completely different. But the interface is the same. And so this is a great example of when you would use inheritance, right? If you don't, then you would have to have this code copied and pasted 3 times. If hash equals linear, then here's the linear implementation of main. Else, if it's chaining, this big implementation using chaining. Instead, main's exactly the same. And you could switch out the underlying implementation with absolutely no differences in main. The only thing that changes in main is this line right here, where you choose the implementation. Are we choosing linear probing, chaining, or double? That's it. Once you got that, all the code's the same down below. It's really nice. So don't think that inheritance is terrible or bad or something like that. It's very useful. I just kind of had a professor that was really into it, and it took me a while to like, I don't know what the right word is. Real life kind of punched me in the face. Like trying to actually make a complicated class hierarchy work turned out to be more effort than it was worth. And I sort of overreacted for a while and went back into SeaWorld, where it's simpler days. There's basically no inheritance. You have structs, to do the things you need to do. And I had member functions and things like that. It was just very C like C++. But nowadays I have sort of a more nuanced view on it, I guess. How do you inherit a function that's been implemented in every class? What do you mean inherit a function? You don't inherit functions, you inherit classes. And when you inherit from a class, you get everything in the parent class and the subclass. Does it actually go that deep in real life? Yeah, sure. Microsoft Foundation classes. Yeah, you can see that though. Yeah. Those class hierarchies get pretty big. If they're organized well, it's not too bad. If they're organized well, it's not too bad. But a lot of times they just make a new class to avoid an if statement, and that just usually isn't worth the extra overhead. Yeah, so that's your classic inheritance. Every time. I don't know what it is. I don't know why they use that. Because, like, you wouldn't write code this way. You wouldn't, like, I know people write code this way, but, like, I wouldn't write code this way. I wouldn't have a separate class for dogs and cats. No, probably not. Almost certainly I would not write code this way these days. But this is the example they always use. So a mammal is a kind of animal, and a dog is a kind of mammal. So mammal inherits from animal, and dog inherits from mammal. And reptile inherits from animal, and lizard inherits from reptile. And so what they're trying to explain, and I guess I should explain this, so I'm not just completely sarcastic, but what they're trying to explain is there's a difference in copy image. Bring this over into my PowerPoint. Why not? Plagiarism. Level 100. There we go. There we go. Okay. So what they're trying to explain here is the difference between an is-a relationship and a has-a relationship. Okay. So a mammal is an animal, and a dog is a mammal. So anytime you have that kind of relationship, a lot of times it's expressed in inheritance, in object-oriented world, right? So you'd say like class doggo (public) mammal, right? And that means a dog is a mammal. Does that make sense? So dog inherits from mammal. Mammal is a animal, so mammal will inherit from animal. That's the point of using animals, I guess, is that everyone's familiar with it or something. I don't know. So, you don't get it? What's wrong with this? There's nothing wrong. Like, it'll work, like, but like if you're making like a battleship game, right? Would you make a separate class for the submarine and the destroyer and the aircraft carrier and the transport and the battleship? You could. You can make a game piece class and inherit from it a ship, and inherit from a ship the submarine. And do you understand what I'm getting at here? The answer is no. You wouldn't. There's no reason to have a separate class for the submarine and the battleship and the aircraft carrier, because they are all the same thing. They're a piece that goes on the board, and they have one property that's different, which is their size. They don't do anything different. They don't behave differently. They're not different enough to be worthy of having their own class. Let's put it that way. So you can just have member functions that differentiate between them. Yeah, you would instead, rather than using isa, right? Because you could have like a ship class, you know, and in battle, you guys all know Battleship, right? Otherwise, you're going to be kind of mystified. Do you guys all know Battleship? So the ship class, you have the submarine and the transport, and the aircraft carrier and the battleship, yeah, whatever. Right? You could make different classes for all of them. That is a way of doing it, and the code would work eventually. But you're gonna see my reaction to inheritance coming through here. I wouldn't write code this way, and the reason why I wouldn't write code this way is because rather than using isa, I would use hasa. What do you mean by that? Okay, so I would just make a ship class, and the ship class would have a variable on it. So, and that variable would be called size. Okay, and you know the battleship would have a size of 4, the aircraft carrier would have a size of 5, because they're all essentially the same thing. They all do the same thing. They all go onto the board the same way. There's no difference in behavior. There's no difference in anything other than one characteristic, which is size. That's the only thing that varies between these things. That is a dumb reason to have a different class. That's kind of what I'm getting at here. Like, because every time you make a class, your class hierarchy grows, and you have to handle more, you know, worries about, you know, the hierarchy and that kind of stuff. You have to track it and have the printout and stuff like that. And it's not necessary. All you need is an if statement. If I'm a submarine, make the size 3. If I'm an aircraft carrier, make the size 5. All they vary on is their size. And so I would not do any of that. And I would just have a ship class and have has a relationship because it has a size. Does that make sense? And so I don't know what they're doing. Like, I don't know what their code is here even, right? Like, you know, it's such a contrived example, right? And they're going from like animal, which is like, what is an animal? What does an animal do? I don't even know. To like, you're getting to like these large ontological categories, and then you're going from a category of animal to a specific animal, which is probably wrong. If you think about it, it's probably wrong. What it probably should be is you should have a mammal class. I don't know, can write mammal now, mammal, and call it dog, right? And then the mammal class will have member variables for tail and legs. And I don't know what they're doing with it, but and just these don't need to be classes, right? Probably none of these need to be classes. Maybe, I don't know, snake maybe. Like if they do something significantly different, like if they can poison people, I don't know. But like lizards, some lizards can poison people, so probably it should just be up here, you know, like poison, you know. And you will see this reaction from me all the time, which is that I try to eliminate any complexity out of my class hierarchy as much as possible. Does this really need to be a different class? You'll hear me say that a lot. Does this need to be a class? And the answer is usually, in contrived examples, no. Right. It's unnecessary when you're changing one variable. Yeah. The only difference, yeah, it's not even like they have a different variable. It's all the same variable. It's just one square extra in size or less or whatever. If you're making Monopoly, like, would you want to have a different class for the boot and as for the thimble? No. Why? They're all the same. They look different, right? The tokens, you know, on the Monopoly board, the race car, whatever, they all look different. But they're not actually different. They're all the same. And so I would not do inheritance with that either. I would have it be a game piece class, and you have a string on there that holds a path name to where the 3D model is. That's the only difference. Right? If I'm making an RPG, then gaming. Yeah, we might have like an entity class. This is pretty common, an entity or an actor class, you can call that. That's anything that can go in the world, and then maybe you make a class off of that called like player character, and that's like anything that can be moved by the player, like the Doom guy, something like that. And maybe you have different options in this. I don't know, you know. And then you can have over here like NPCs or something. And these are pretty different, right? Like player characters have to worry about things like keyboard and mouse events and game controllers and things like that. NPC controllers have to worry about things like AI. Those are probably different enough that I would put them into different classes, right? But at the same time, they can both walk around on the world. Their movement modes are probably similar. So I'd probably have a class called like Pawn. This is how UE4 does it. Pawn inherits from actor, and then mammal player character, and you know NPC character might inherit from Pawn, or you know something like that. Like, and this would handle things like how to walk around and jumping and anything that's shared between them. And so there's a lot of thought that has to go into these class design questions. And then, yeah, like a lot of people will make like a hero class and a monster class. And then the hero class, like if this is a hero class, then you might have like fighter and rogue, wizard. And yeah, you could do it that way. I've seen it done. I've seen people design games this way. I wouldn't do it myself. Maybe. I don't know. It depends how different they are. If these things are radically different, yeah, probably. They're pretty similar, but just have like different stats. Like if the only difference between a fighter and a rogue and a wizard is like the fighter has like a health of 100 and the rogue has a health of 60 and the wizard has a health of 40. No, they don't belong as different classes. Use has a instead. Do you understand? So is a and has a. Okay. So sometimes you want to do one, sometimes you want to do the other, and it really just boils down to like, okay, is the only difference the starting stats? Then no, they should not be different classes. Okay. Hostile, docile NPCs. Yeah, you could have separate NPCs here for like, you know, friendlies maybe, and like hostile. Yeah, you probably do something like that, sure. Depends. You know, there's no one answer here, and I hope that's coming through because I am very prejudiced on this subject, just from years of bad experience with inheritance. But there are a lot of answers to this problem, and you can solve it in a lot of different ways. Right? You could have separate classes for, you know, fighter, rogue, and wizard, even if all their differences are the starting points in health and money or whatever. You do it. You know, personally though, I would use Haza instead if that's the only difference. Good. It's like having a separate class for each Pokemon type, yeah, or a separate class for each Pokemon. Right? Yeah, nobody wants to make 900 classes. Have your class diagram up on the wall. This function can only take Bulbasaurs. Okay. Well, I want to pass the evolved version of Bulbasaur to Venusaur or whatever. Oh, shoot. So, does Venusaur inherit from Bulbasaur? Does that make sense? Does Venusaur inherit from Bulbasaur? Does Bulbasaur inherit from Venusaur? Is Venusaur a Bulbasaur? Is Bulbasaur a Venusaur? I don't know. I wouldn't write my code that way. I would make a Pokemon class. And the Pokemon class would have a type on it that's an int, and a move list, and yeah, basically. Health, attack, speed, whatever. It's getting too deep. Yeah, but these are the kinds of questions you have to ask yourself when you get into inheritance. And, you know, like design. Like you have to design you have to architect your software. And yeah, at some point somebody has to make a decision. Like, are we going to have one Pokemon class? Are we going to have one Pokemon class for each type of Pokemon? Ghost and Bug and whatever. That's one way you can do it. You can implement it any of these ways. None of them will stop you from finishing your software development. But you have to think about it. Like, do we want to have 900 classes? Maybe the answer is yes. I don't know. Yeah. How do you do inheritance between different versions of a Pokemon? Or are all three of those one? I don't know. I wouldn't. I would make a one Pokemon class. And, you know, when you have one Pokemon, a fire type, getting hit by a water attack, you just check its type, check the type of the attack. Okay, it's got a highly effective bonus. You know, that's how I do it. Whereas a lot of people that I know would have probably a separate type for a separate class for fire Pokemon, and then if you inherit from, like if you're fire and ghost type, then it would have to inherit from both of those, and then they would abuse the type system to avoid an if statement. So they would say they would have a separate function essentially for like attack type water, defender type fire, and so you'd have an exponential explosion of all the different functions to do damage in all the different combinations. I would not do that. I would use a table, and I would have a number and like type water, attacking, type fire. Okay, it's highly effective. You know, whereas a lot of people are scared of if statements for some reason, and they would rather use the type system and let the type system figure out all the different combinations of damage. But that means that they have to write n squared functions to handle all the different ways that types can combine with each other. I don't want to do that. I don't want to write 400 functions. No. Give me an if statement instead. Seems like a lot of work to avoid an if statement. Okay. Yeah, sorry. I have run over, but I will rant on inheritance for all day long. Take notes. I want to redo Pokedex with what you've learned in this class. I don't think you need to. I think the way that you did it last time was just fine. Seriously. I wouldn't do inheritance with it. All right. But you could, if you want. Try it out. We'll pick this up on Friday. All right. See y'all.